Howdy, my peoples. Lesson 4.4 is using corresponding parts of congruent triangles. You may remember back in the day when we talked about what congruent figures are. It's figures that have all corresponding parts congruent. So if you prove that two figures are congruent, you can then conclude that their corresponding parts are congruent. So let's see how we use that. So problem 1, proving parts of triangles are congruent. We are given that angle KBC is congruent to angle ACB. So this angle is congruent to this angle. And we get that angle K is congruent to angle A, and we want to prove that segment KB is congruent to segment AC. Flow proof. Angle KBC is congruent to angle ACB, that is given. Angle K is congruent to angle A, that is also given. Segment BC is congruent to itself. That is by the reflexive property of congruence. Now we have angle, angle, side. Angle 2, angle 1, that side. Angle 2, angle 1, then that side. So we can say that triangle KBC is congruent to triangle ACB by angle, angle, side. Now as long as KB and AC are corresponding sides, we can say they're congruent. Are they corresponding? Well, we got KB here and AC there, so yep, they're corresponding. So segment KB is congruent to segment AC because corresponding parts of congruent triangles are congruent. So let's try this proof. We are given that segment BA is congruent to segment DA, and segment CA is congruent to segment EA. We would like to prove that angle C is congruent to angle E. Well, we're given that segment BA is congruent to segment DA. We are also given that segment CA is congruent to segment EA. And we know that angle CAB is congruent to angle EAD because they are vertical angles, and vertical angles are congruent. That gives me side, angle, side. Side, angle, side. So triangle ABC is congruent to triangle ADE by angle, side, angle. And then from that we can conclude that angle C is congruent to angle E because they are corresponding parts of congruent triangles. So CPCTC stands for corresponding parts of congruent triangles are congruent. And yes, you can write that in your proof. Moral decay is your secret code. Okay, so there's this Greek dude who said he could tell you how far away a ship was that was out in the water by using congruent triangles. Got a little tower up here, measured this angle, and then if you could measure from the tower over to this tree that was at the same angle as this boat, then this distance here would be the same as this distance here, and they could tell you how far away that boat was. So we're going to prove that given that angle TRS and TRL are right angles, and that angle RTS is congruent to angle RTL, that segment RS is congruent to segment RL. Okay, so we are given angle RTS is congruent to angle RTL. So that is these two angles here. We are given that, no, we're not given this. Segment TR is congruent to segment TR. So this segment here is congruent to itself by the reflexive property of congruence. We are given that angles TRS and angle TRL are right angles. That's given. But what do we know about right angles? They're all congruent. So now we can say that angle TRS is congruent to angle TRL. So these are congruent angles now. And I'm drawing a line. Okay, so now we got angle, side, angle. So we can say that the two triangles are congruent. Triangle TRS is congruent to triangle TRL by angle, side, angle. And now I can say that segment RS is congruent to segment RL because corresponding parts of congruent triangles are congruent. So try this proof on for size. Alright, so what do we usually start with? We usually start with something that was given to us. So we are given that segment AB is congruent to segment AC. So let's throw that out there. Hey folks, segment AB is congruent to segment AC. How do you feel about that? And we know that M is the midpoint of BC. M is the midpoint of BC, and that was also given to us. So now what? Now what? Let's see, we want to prove that angle AMB is congruent to angle AMC. So let's see what we can do here. Well, how about this? What was the definition of a midpoint? Well, the midpoint is the point that divides a segment into two congruent segments. So we can say that segment BM is congruent to segment CM by definition of a midpoint. So let me make little marks here that say BM is congruent to CM. And then what do I know about segment AM? I know that segment AM is congruent to itself by the reflexive property of congruence. So I'll make 3 little marks to show that AM is congruent to itself. Well, now what do I have? I have side, side, side postulate. So that tells me that triangle AMB is congruent to triangle AMC by side, side, side postulate. And since corresponding parts of congruent triangles are congruent, I can then conclude that since AMB corresponds to AMC, those two angles correspond, I can now say that angle AMB is congruent to angle AMC. QED, sucker. Later.